You have studied differentiation, right? Now, you know that what is differentiation of a function, how to find it. You have studied so many rules. Now we are going to study indefinite integration. So for that, we must know something which is called as primitive or antiderivative. First, see this example. If I choose this color, say red color. Okay. Hmm. Now you can see, first see this example. Now you, if you differentiate this x to the power 4 by 4, what will you get when you will differentiate it? You have 4x to the power 3 upon 4, 4, 4 cancel out. So you have x to the power 3. So differentiation of x to the power 4 upon 4 is x cube. Similarly, this x cube because
Nisha
the
ma'am,
differentiation
voice,
of
voice.
constant is 0.
Ma'am, your
So
voice,
differentiation of 1 is
ma'am, your voice is cracking.
voice is breaking.
Yes, yes.
Okay. I don't know why it's so. Network is fine. Let me change my network on this tab. Uh, I'm connecting through hotspot. Let's see what happens. Is it okay?
Yes, yes, ma'am, it's okay.
Okay. Okay. So the differentiation of x to the power 4 by 4 plus 1 is x cube. Similarly, if you differentiate x to the power 4 upon 4 minus 2, then again you get x cube. So what you see when you find the differentiation of these functions, when you find differentiation, you are getting x cube. You are getting differentiation of this. When you have this function, you are getting differentiation of this. You have this function. So infinitely many functions are possible whose differentiation is x cube. Okay. So these are called primitives of x cube. These are called primitives of x cube. Okay, so what are primitive? Primitive means you have function, you have family of functions whose derivative is giving this x cube. Okay, so let's see this definition. If fx and gx are two functions of x, then gx is called primitive or antiderivative of fx if its derivative is fx. So you have these functions whose differentiation, whose derivative is x cube. So what are you doing? You are getting differentiation of these function as x cube. So this means that when you will integrate this x cube, you will get what? You will get these functions. You will get these functions. So what do you mean by antiderivative or primitive means whose differentiation is giving that function? So that function is called as antiderivative of that function, means of x cube in this example. So what I want to say, the differentiation of gx is fx, differentiation of gx is fx. So integration of fx will be this gx. Integration of fx will be this gx. But what is the difference? For differentiation, whenever you are differentiating, you are getting the same function x cube every time. But this x cube has so many derivatives, anti derivatives. Okay, so collection of all these family will give the integration of this x cube. So what does it mean? Means when you integrate this x cube, you have what? You have all these derivative of this kind x to the power 4 by 4 plus C type. Okay, so let's see here. So family of all primitives or antiderivatives of fx is called what? Indefinite integral. Okay, so differentiation of gx plus c is what? Fx You know, by this example, differentiation of I took there x to the power 4 by 4 in place of gx. So you know that the differentiation of all functions of the kind gx plus c is fx. This means that integration of this fx is this gx. Okay, so you are going after differentiation from gx plus c to fx, and when you will integrate fx, you will get gx plus c. So this is the definition of indefinite integration. Integration of fx dx is what? Gx plus c. The family of all those functions whose differentiation will give you fx. Okay, so integration of fx will be gx plus c. What is c here? C is constant of integration. Okay, and this sign like this called integration sign, integral sign. X is here variable of integration, because you can have a function in terms of t like this. Okay, so in this case the variable will be t, but in here the variable is x. So x is what? It is variable of integration. And what is fx? It is called as integrand. Okay, the function which we are going to integrate. Okay, so these are basic things for the indefinite integral. So you must keep in mind that indefinite integral is nothing but the family of all antiderivatives of fx. Okay, or you can say the collection of all those functions whose derivatives is giving that function fx. Now these are some fundamental integral formulas, and the list is also shared by Parth of formulas for you. So you have to memorize all those formulas. Okay, I have also mentioned so many more formulas in this PDF, so I'll share with you also. So you must remember all these. Now you can see in this, these are basic things. You know that if you differentiate this, okay, Parth. Uh, you will, if you differentiate this x to the power n plus 1 upon n plus 1, you will get x to the power n. How? You know the rule of differentiation. What is the rule of differentiation? Actually, I'm not explaining that. You just a minute. I'm just telling this to you because I cannot explain every formula of differentiation again now here. So you know that differentiation of x to the power n is what? N x to the power n minus 1. Okay. Similarly, if you differentiate x to the power n plus 1 upon n plus 1, what does it give? If you differentiate it, n plus 1 x to the power n, one power will be reduced. Okay, and here n plus 1 in the denominator will be as it is. So you have this n plus 1 cancel out. So you have x to the power n. So it is given in this first formula. Okay, so differentiation of x to the power n plus 1 upon n plus 1 is x to the power n. Keep in mind n is not equal to minus 1. Okay, so here its integration is given. So differentiation of this function x to the power n plus 1 upon n plus 1 is x to the power n. This means integration of x to the power n is x to the power n plus 1 upon n plus 1. Okay, so you have to remember that the 1 will be added in the power. Okay, in the power of x, 1 will be added, and the same increased power will be in the denominator. So there is n plus 1 in the power of x, and n plus 1 is also in the denominator, and plus c constant of integration. Okay, you know that differentiation of log x is 1 by x, so integration of 1 by x is log x. Okay, and plus c is also there. Integration of, sorry, differentiation of e to the power x is e to the power x, so differentiation of e to the power x is also e to the power x plus c. Okay, similarly all these are defined. Okay, so if you know the differentiation of one function, then easily you can write its integration. Now let's do this, some of these equations. Now you have to find integration of x to the power 4. So if you apply the formula of x to the power n, integration of x to the power n, so according to that, it is what? It is x to the power 4 plus 1 upon 4 plus 1 plus c. Means it is x to the power 5 upon 5 plus c. I have used the first formula, this one. Okay. Next one is 1 minus x under roots. So to find its integration, you can multiply by under root x in the bracket. So you have under root x, or you can say x to the power 1 by 2 minus x to the power 3 by 2 dx. So this is equals to what? Again, you can apply the same formula. 1 will be added in the power of x. So it is x to the power 3 by 2 upon 3 by 2 minus x to the power 3 by 2 plus 1 is 5 by 2 upon 5 by 2 plus c. Okay. So this is the answer of this integration. Then next one is half sec square x. So you can see that integration of sec square x is what? This 10x plus c. Okay. So directly you can apply the formula and you can see that 1 by 2 will be as it is. Integration of sec square x is 10x plus c. Okay, or you can write directly like this, and no need to put bracket. It's sec square, integration of sec square x is 10 square 10x plus c. It is fine. Okay, so is it clear to everyone? Okay, Arnab, Jasim, Zorli. Okay, these are some standard results on integration. K time fx is k time integration of fx, means I have this property I have actually used in the previous question. There was 1 by 2 in this example, so 1 by 2 will be as it is. Then integration of 10 square, sec square is 10x, and then plus c, constant of integration. Okay, and integration of fx plus gx is equal to integration of fx plus integration of gx, and if it is minus sign is there, then minus sign will also be there. So integration of sum or difference of two functions is equals to the sum or difference of their integrations. Okay, so it is distributed actually in the function, and this holds for finitely many functions. Okay, there can have if fx and gs are two functions here, but there can be more than two functions. Okay, so if they are in addition or subtraction, there is no problem. Integration is distributed. Okay, now these are some identities, trigonometric identities, so you must know all these. Now there are some examples. um, Let's do this first question. In this, you have 2 upon 1 plus cos 2x dx. Okay. Now you have to find the integration of this function. So you must know what is the formula for cos 2x. Okay. So I have written here three formulas for cos 2x. In the previous page, there are three formulas for cos 2x. So you have to decide which one is to use. So you can see that in this example, there one is in plus. So you must choose cos 2x so that this one cancels out. So I'm taking the formula number 5 for cos 2x. Okay. So this is equal to 2 upon 1 plus 2 cos square x minus 1 dx. 1 cancel out, then 2 is also cancel out. So you are left with 1 upon cos square x dx. And this is equals to what? This is sec square x dx. And you know that the integration of sec square x is uh, solely y to 10x. Yes, so it is 10x plus c. Okay. Now can you do the next one? B part. Here you have 10 square x. So for 10 square x, what will you do? You can see that you can use this identity number 2. So according to this, you have 10 square x is what? Sec square x minus 1 dx. Okay. So integration of sec square x is 10x, and integration of 1 is x plus c. Okay. Integration of 1 is x. Why x? Integration of 1 is x. Keep in mind. When you will use the formula of x to the power n, and this is 1 is x to the power 0. Okay, x to the power 0. So this is what? 0 plus 1, 1 upon 1. Okay, so x plus c. Then the c part. What happens in c part? How can you write it? X cube. You can take x square in the common from these first two terms. So you are left with x minus 1 in the bracket. Then 1 as common. Okay, so you have x minus 1. You can write like this. Now you can divide by x minus 1 in both. So you have x square plus 1. Or you can take common x minus 1 like this. So you have this one. Now x minus 1 cancel out. So you have x cube by 3 plus integration of 1 is x and then plus c. Okay, yes or no? So in this way you can do integration. So these are some examples based on formulas. Now these are some also some formulas for integration. These are of the type x square minus a square, or a square minus x square, or x square plus a square, or there is under root. Okay, like that. So you must remember all of these. These are some other formulas where these all are functions of ax plus b. Okay, so I'm first going to discuss the method of substitution, integration by substitution. Then I'll discuss some examples. So what is method of substitution? How to integrate by using the substitution? So you must know how it is defined. According to this, if you have integration of a function f, which is function of phi x, okay, and its derivative is there in the multiplication. Okay, so what you do, you take this phi x as t, then you differentiate in both sides. So when you differentiate both sides, what do you have? When you differentiate fx phi x with respect to x, so how will you differentiate? Because you have equation phi x equal to t. Now you differentiate this with respect to x on both sides, right? So you have actually this. Now d by dx of fx phi x can be written as phi dash x, because when we were studying differentiation, I told you notations like we write dy by dx or f dash x, you know, if y is fx. So this you can write this notation. If y is fx, so differentiation is f dash x. That is why differentiation of phi x can be written as phi dash x equal to dt by dx. So actually in integration we have like this, phi dash x dx. So that is why we write it like this. Okay, so you have phi dash x dx equal to dt. Okay, now you substitute in the given integration and you have this, because this become phi f phi dash x is f phi x is ft, and this phi dash x dx is dt. Okay, so you have integration of this form, integration ft dt. Now let's do question based on this method of substitution. So you have the question integration x under root 1 minus x dx. Okay, now what can you do? Suppose we let under root 1 minus x equal to t. So here 1 minus x is t square. So x is 1 minus t square and dx is minus 2t dt. So why I am doing this by method of substitution? Because under there is under root on under 1 minus x. Okay, so what can we do it now? After this assumption, how this integration, suppose this is I, so I is what now? Under root 1 minus x is t, or okay, you have this t, your dx is converted to minus 2t dt. Okay, so it will make it easy. Now what is x? X is equal to 1 minus t square. Okay, now this whole is converted in terms of t. So we are using this to simplify, okay, to make the integration easily. So x is what? X is 1 minus t square, under root 1 minus x is t, and dx is minus 2t dt. Now it is equals to what? This is integration 1 minus t square and minus 2t square dt. This is minus 2t square minus minus plus 4t to the power 4 dt. Now when you integrate, so what do you have? Minus 2t cube by 3 plus 4t to the power 5 by 5. Okay? Yes. You have this. Is it okay? Now you can substitute back the value of t. So you will get your answer in terms of x. Because originally the question was given in terms of x. So that is why you need to give it in terms of x. Okay? So you can directly now put back the value of t and you have the answer in terms of x. Are you getting this integration? Okay. Next one is integration of 10x. Can you do it by yourself? 10x is what? Sin x upon cos x dx. And you have to integrate it. Can you apply the method of substitution? Choose a function as one function as t so that it differentiation with dx gives you in terms of t or dt. So what can you take? You can let cos x equal to t. So differentiation of cos x is what? Sin x minus sin x. So minus sin x dx is what? Dt. So you can see that value of sin x dx is what? Minus dt. Sin x dx is what? Minus dt. So you now you can replace it. So this is what? Minus dt upon t. Okay. Now what is integration of 1 by x? Integration of 1 by x is ln x. Ln mod x plus c. So this minus sign will be as it is, and ln mod t plus. Now you can substitute value of t minus ln mod cos x plus c. Okay. And you can also write it as ln because according to the property of log, this minus will go in the power of here of this mod cos x, so which will be equal to sec x. Okay, so you can write it as mod sec x plus. Okay, both are correct. You can leave as this step, or you can write also this step. Okay, similarly you can do for cot x. So cot x is what? Cos x upon sin x. Okay, so as we did in case of 10x, the denominator is taken as t. Similarly, you can take sin x as t and you will get the answer. So I'm not doing it, you can try it by yourself. Is it okay? Are you getting it? Vivek, Manish, Shivai, Arnav. Okay. Can you tell me in the next one, which function is to be taken as t? Which function is to be taken as t? Can you tell me? Yes. So here you will take sine inverse x SD. Okay, great. Because the differentiation of sine inverse x is 1 upon under root 1 minus x square. Okay. So then mm, uh, you will find integration very easily. Okay, so I hope you can try this one also. Good. Okay, so let's do this next. This is actually a formula. So we'll do examples based on it, but I am going to discuss this one only here. So in this integration formula, you have integration of 1 upon x square minus a square with respect to x. So this is actually what? This is 1 upon 2a ln of mod x minus a upon x plus a plus c. So how to integrate such a function? So when you have x square minus a square in the denominator, so you can factorize it by using the identity of a square minus b square. So this comes out to be integration of 1 upon x minus a or x plus a with respect to x. Now you need to do it partial fraction. So I will later today tell you how to find partial fractions. But here I have found it very easily. Why? In the numerator you have nothing, means there is one only. So what can you do? You can write it as uh, x plus a minus x minus a. Why? Because x will cancel out and you will be left with 2a. 2a will be there and I have written 1 upon 2a outside. So when 2a will be cancelled out, so you will be left with 1. Okay. So that is why we can write this function like this. Okay, so after putting this, there is another way also for doing partial fraction, but don't worry, I'll tell you. So this is one way to find the partial fractions. Okay, so this gives these terms. Okay, and we know that what is the integration of 1 upon x minus a, because you know that differentiation of ln x minus a is what? 1 upon x minus a. Okay, so integration of 1 upon x minus a is um, ln mod of x minus a. Similarly, 1 upon integration of 1 upon x plus a is ln mod x plus a. Okay, and plus c. So after combining these two and using the log property, you have left with this ln of this fraction. Okay, so in this way you have this formula 1 upon 2a ln mod x minus a upon x plus a plus c. So how can you apply? See this in this example. I have done it in two ways, by using substitution or by doing directly. So in this example, you can see that you have dx upon x square minus 4x minus 5. It is not of the form x square minus a square or a square minus x square and nothing. Ma'am, I have a doubt. Why do we have modulus of x minus a? Ln sign is there, na? Because ln is there. Okay. You know that log function is defined only for positive values, not for negative. Then now in this question one, this is not of the form x square minus a square or a square minus x square or like that, for which we have formulas. So we need to convert this. So we have function x square minus 4x minus 5 in the denominator. So what can we write? First we make a perfect square. So how to make perfect square? See, whenever you have coefficient of x as 1, okay, so what you have to do to make perfect square, what you have to do, you have to take coefficient of x, okay, and divide by 2 and then whole square. So to make perfect square, what to do? You have to take coefficient of x, okay, divide by 2, make it, take its half of the coefficient of x and do its square. So that term, that square term is to be added and subtracted to make the perfect square. So what can you see in this? X square minus 4x, here the coefficient of x is 1 and coefficient of x is 4. Okay, you can also ignore the negative sign because we have to add square. Okay, so coefficient of x is 4. So 4 by 2 is 2. So what will you do? You will add 2 square and minus 2 square. Okay, you will add and subtract 2 square. So I have done that. So x square minus 4x plus 2 square and minus 2 square. So when you have in one bracket x square minus 4x plus 2 square, this is what? This is actually the square of x minus 2. And then you have here minus 4 minus 5, which is 9. So 3 square. Okay, so now we have a function of the form x square minus a square. And in place of x, we have only x minus 2 factor. That is linear factor. Okay, so we have square of x minus 2 and then minus 3 square. Okay, in place of a, we have 3. So if we directly apply the above formula that we discussed just now, so according to that, what was formula? Formula was this: 1 upon 2a and ln of mod x minus a upon x plus a. So 1 upon 2a. So 1 upon 2a means 1 upon 2 into 3. Then ln of x minus a means x minus 2 minus 3. And x plus a means x minus 2 plus 3. Okay. So this comes out to be this. Or what you can do? You can suppose x minus 2 as t. Okay. So you have this question converted in this form: dt upon t square minus 3 square. So it is of the form x square minus a square. Only the difference is that you have t here in place of x in the above formula. So you can apply that formula, you have this answer in terms of t. And that then putting back the value of t, you will get this answer. So are you all getting this integration? Is there any someone who is find difficulty in solving these questions? Is there anyone? Are you all comfortable with this integration? Because I don't know how many of you have its strong background or weak background or no background of integration. Is there anyone who does not know anything about the integration? Second step. Second step, this x minus 2 whole square minus 3 square. Arna, or its previous step. After that, only I have simply used the formula. I have applied the formula only. Okay, Vivek. Arnab, I have only applied the formula here. Should I explain it again? Okay, okay. See the next formula of integration. This is giving you the integration of the function of the form 1 upon x square plus a square. Okay, and this is defined as this: 1 upon a tan inverse x upon a plus c. So plus c will be there. Okay, you are doing indefinite integration. Plus c will be there. Okay, so 1 upon a tan inverse x upon a. You have to remember this. So in this example, you don't have function of this form x square plus a square. So just focus on making the perfect square. So, uh, okay, Arnav. So I told you that if coefficient of x is 1, so what you have to do? You have to uh, define the half of the coefficient of x. So coefficient of x is 6 here. 6 by 2 is 3. Okay. Now what will you do? Now you will add the square and square of this 3, and you will subtract this square of 3. So 3 square is added and subtracted. Why 3? Because 3 is what? 3 is half of coefficient of x. Okay. Coefficient of x is 6. 6 by 2 is 3. So you are adding 3 square and you are subtracting 3 square. So when you take these two terms with this 3 square, you can apply identity. So identity of what? Identity of x plus 3 whole square. Okay. Then you have 9. So now you have what? You have x plus 3 whole square plus 3 square. This is of the form x square plus a square. Okay. Only difference is that you have this linear factor x plus 3 in place of x. Okay. So what can you do? Now what will be the integration? So you can apply the formula. So this is 1 upon a. A means 3 here. Okay, 1 upon a, 1 upon 3. Tan inverse, formula is tan inverse x upon a. So tan inverse x, in place of x, you have x plus 3 upon a. A means 3. Are you getting it? Or you can also do it by taking x plus 3 equal to t. See, whenever you have formula for x, okay, and you are applying it for linear combination of this like x plus a or x minus a, then you can apply directly. So in this question, you have x plus 3 in place of x, you can apply directly. There is no problem because these both have same differentiation. Differentiation of both is equals to 1. So there is no problem. But you cannot do for another thing like if you have formula for x, so in place of x, if you have suppose x square plus a, then you cannot apply, or x square plus something. Okay, so I think you are getting my point. Here you have x plus 3 whole square, and the formula for was x square plus a square, and here you have x plus 3 whole square plus 3 square, which is a square. So x is replaced with x plus 3, so that is linear factor in such that both have same differentiation, or otherwise you can do it by taking x plus 3 as t by using substitution method. So you can also use that. Okay. Otherwise, if only a constant is added or subtracted, so there is no problem. You can apply that formula by replacing x by x plus 3. Okay, so in this way you have this one. Is it okay to all? Okay, good. See the next one. In the next one, what do you have? You have integration of 1 upon under root x square minus a square. Okay, so you must have a function of this form x square minus a square, but you have this polynomial of degree 2 x square plus 16x minus 17 in the denominator inside the under root. So what you can do again, you will add and subtract the square of 8 square. You will square of 8. Add and subtract square of 8 means 8 square is added and subtracted. Why 8 square? Because 16 by 2 is 8. Okay, so coefficient of x is 16. 16 upon 2 is 8. That is why we are adding 8 square and subtracting 8 square. Okay, so first three terms, uh, what does it give? X square plus it is removed. I don't know why. Okay, so what do you have? First three terms are these x square plus 16x plus 64. Then 8 square is 64 and minus 64 and minus 70. When you will add these two terms, these two last term, you have minus 81. So minus 81 is minus 9 square, and first three terms give x plus 8 whole square. So in the identity you have, in the formula you have under root x square minus a square, but here you have the function like this, dx upon under root x plus 8 whole square minus 9 square. Okay, so you can apply the formula because you can replace x by x plus 8. We both have same derivative, or you can replace x by x plus 8 by t. Okay, so there is no problem. So I have done directly without taking t. So by putting in the formula of this log x plus under root x square minus a square plus c, this is the answer. Okay, when you will apply formula, you have the answer. Are you getting it? Vivek, Shivai, Manish, Arnav. Okay. Similarly, you have next one. In this, the formula is for the integration of 1 upon under root a square minus x square. Okay. So this is what? This is sine inverse x upon a. You can see in the formula of tan inverse, there was 1 upon a tan inverse x upon a. Okay. And there was plus, no under root. And in this formula of sine inverse x upon a, under root is there, and in the under root you have a square minus x square. So again you will make it perfect square. So I have taken minus common. So this is the term. Okay, now the coefficient of x is 4. 4 by 2 is 2. And 2 square is, this is 2. 2 square is 4. So you have to add 4 and subtract 4. So when x square plus 4, x in this 4 is added and subtracted, and minus 5 is there. So the first three terms gives x plus 2 whole square minus 9 means 3 square. Okay, there was some this minus sign outside, so by multiplying this minus sign you have this. So this is of this form, a square minus x square. Okay, now if you apply the formula you have this integration. Okay, so sin inverse x upon a, so in place of x you have x plus 2, and in place of a you have 3. So this is sin inverse x plus 2 upon 3 plus c. Similarly, you can understand this next one. Here the formula is for 1 upon under root x square plus a square. The previous one was for 1 upon under root a square minus x square. Okay. So again here this denominator function x square plus 4x plus 5 is to be make as perfect square. So coefficient of x is 4. 4 by 2 is 2. So you have to add and subtract 2 square and subtract 2 square. So what will you get? These three terms are giving x plus 2 whole square, and then minus 2 square plus 5 is plus 1. So this is plus 1 square. So in this case your a is 1 and x is replaced with x plus 2. Okay, so you can apply the form. So is this okay? So are you all comfortable with this and can apply these identities in such questions, such formulas, such identities? Okay. Now there is one most important formula, and this formula is used in many places. In many branches of mathematics, you will see that this formula is used. So according to this, the integration of f dash x upon fx means if you have a function in the denominator such that its derivative is present in the numerator. Okay, so fx is in the denominator and derivative of fx means f dash x is in the numerator. Then integration will give what log of denominator function. Okay, so if you have any question like that, its derivative is present in the numerator, so integration becomes um, log of the function. Okay, just a minute. Yes. So you can see in this question integration of tan x. Tan x is sin x upon cos x. Okay. Now you have cos x in the denominator and differentiation of differentiation of cos x is what? It is minus sin x. So whether its differentiation minus sin x is present in the numerator. So you can see that sin x is there in the numerator but not minus sin x. So if you multiply by minus sign inside and outside, okay, then what you have, this minus sin x is there. Okay, so its integration is what? This outside minus sign as it is, and this function minus sin x upon cos x becomes this ln mod cos x. So integration of this becomes log of the denominator function plus c. So whenever you have a function in the denominator such that its derivative is present in the numerator, so keep in mind that the integration of whole function, whole rational function will be the log of the function in the denominator. Okay, and we are talking about log function, that is why modular sign is there. Whenever you are dealing with log, so you will put a modular sign. Similarly, you can check for the next one. You have in the denominator x square plus 5x minus 7. In numerator, it is 2x plus 5. And you know that if you will differentiate this x square plus 5x minus 7, so what do you have? You are left with 2x plus 5. Okay, so actually you have this 2x plus 5 is what? Actually, it is differentiation of the numerator. It is like this. Okay. So according to the formula, if the situation is like this, f dash x upon fx, this gives ln of mod fx. So the answer is what? Ln of mod x square plus 5x minus 7 plus c. Okay. Can you do it? Are you able to understand it? Okay, Arnav. What about others? Are you all getting? Okay. Jasleen, Arnav. Okay, Vivek. See the next one. Integrals of the form px plus q upon ax square plus bx plus c. In the previous formula, you can easily integrate if you have function in the numerator which is the derivative of the function in the denominator. Okay, but it is not possible always in all cases. So if you have any function px plus q in the numerator, okay, and denominator there is quadratic polynomial, means linear polynomial is in the numerator and quadratic polynomial is in the denominator, and it is not necessary that this linear polynomial in the numerator is derivative of the quadratic polynomial in the denominator. Okay, if this is the case, then how to find the integration? So what you do, you write this px plus q as the linear combination like this, means you write lambda times d by dx ax square plus bx plus c plus mu. Okay, so what you do after differentiation, you have this. Okay, now you compare on both sides and you find lambda and mu. So in this way, and what is this actually? This differentiation of this is what? Actually this is 2ax plus b. Okay, so you have this. So what are we doing? So any for linear polynomial px plus q is written like lambda times of 2ax plus b plus mu. Okay, so why? So how it will help? Yes, Arnab, I'm explaining. Just see here. We actually write like this. You can this step one you can understand from this also. I have written here in this box, red box. So what you do, you write this px plus q as like this, lambda times 2ax plus b plus b. Okay, what is 2x plus b? It is differentiation of the function in the denominator. Okay, because we know that if we have function in the numerator, which is differentiation of the function in the denominator, then we can apply the result that we studied before this. Okay, but it was any linear polynomial general, so we can break like this. Okay, so this will help in solving the integration. Now the question is how to find lambda and mu. So what will you do whenever you have such step? Then you will multiply by lambda. So you have 2a lambda x plus b lambda plus mu. In the left hand side you have px plus q. So what you do? You compare the coefficient of x. So you have p equal to 2a lambda, and you compare the constant terms. So q equal to b lambda plus mu. Okay, suppose this is first equation, this is second equation. So first equation gives lambda. Using that into this second equation will give value of mu. So I am going to discuss with you one example based on it. See here. In the denominator, you have function x square plus 3x plus 2. Okay, this is quadratic polynomial. In numerator, you have linear polynomial. But this linear polynomial is not the differentiation of this quadratic polynomial. Okay, it is any polynomial, any linear polynomial. So what you can do? You will write like this. This 4x plus 1 is lambda times derivative of the denominator, which is 2x plus 3 and plus 3. First you will write this step, then you will multiply by lambda. So you have 2 lambda x plus 3 lambda plus 1. And left hand side 4x plus 1. Now you compare the coefficient of x. So what do you have? You have this 2 lambda equal to 4. So 2 lambda equal to 4 gives lambda equal to 2. Okay, so you have lambda equal to 2. Now, comparing the constant term, you have 1 equal to 3 lambda plus mu. 1 equal to 3 lambda plus mu. Using lambda equal to 2 here, so you have mu equal to minus 5. So, what has happened now when you have lambda and mu? So, what can you do? You can use this first step. 4x plus 1 equal to lambda times 2x plus 3 plus mu. You can substitute lambda and mu here, and you can replace 4x plus 1 by this. So, what do you have? You have this step. Lambda times 2x plus 3 and mu is minus 5. Okay. Now, you divide by this denominator function in both the terms. The first term will give this and second term gives this. Okay. Now, this first is what? This first is what? You can apply here the previous result. Integration of f dash x upon fx. So this will give you, this gives log of the denominator. So you can see that this is, I have written here, log of the denominator, because its differentiation is present in the numerator. Okay. Now for the next term, in the next term it is required to have um, perfect square. Okay, because it is of the form x square plus 3x plus 2, and we have the formulas for x square minus a square or x square plus a square, like that. So you must make it perfect square here. So what will you do? Now coefficient of x is 3, and 3 by 2 is the half of the coefficient of x. Now what will you do? You will add square and square of 3 by 2. Okay, you will add the square of this, and you will also subtract this. So 3 by 2 square is added and subtracted. So first three terms gives this x plus 3 by 2 whole square, and last two terms gives this minus 1 by 2 whole square. Okay, now when it is substituted here, so you have the formula of integration here. You can apply the formula of 1 upon x square minus a square. Okay, so 1 upon x square minus a square. Using that formula, you have this term. So it is actually what? 1 upon 2a ln x minus a upon x plus a. So using that formula, you have x plus 3 by 2 in place of x, and you have 1 by 2 in place of a. So using that formula, you will get this answer. Are you getting this question? If you have any doubt, so let me ask. You can ask, please. Any query, any doubt? Okay, Arnav, what about others? So we discussed the result for integration of fx upon f dash x. Then also one general form px plus q upon quadratic polynomial in the denominator. Okay, and that px plus q was converted as a linear combination of lambda times of the that f dash x. Okay, the differentiation of the function in the denominator, lambda time of that, and plus mu. Okay, so we can do like that. Okay, but suppose if you have but in that there was linear polynomial in the numerator and quadratic in the denominator. But suppose if the polynomial in the numerator has degree um, equal or greater than the polynomial in the uh, denominator. If polynomial in the numerator has degree greater or equal than the polynomial, quadratic polynomial means degree 2 in the denominator. Okay, so what will you do? How will you proceed? So you will divide this px by the ax square plus bx plus c, and then you have this form. Quotient function qx plus rx remainder and upon ax square plus bx plus c. So then, and what will you do then? Then this rx upon ax square plus bx plus c can be integrated by using the formulas that I discussed before this. Okay. So you can see in this, if you will divide x cube plus x plus 1 by x square minus 1, you will get this. How many of you know the differentiation? Or should I explain the, sorry, this division? How many of you know the long division of the polynomials? Px can be any function, yes, any function, any polynomial. Actually, this is polynomial, okay? But degree can be anything greater than equal to 2. So do you know how to divide this in this question? How it is divided for getting this x plus 2x plus 1 upon x square minus 1? Do you know the division? Okay. What about others? Okay. So I'm not doing that division here. So after doing that division, you have this step x plus 2x plus 1 upon x square minus 1. Okay. Now what to do? The integration of x can be easily written. The integration of x is what? X square by 2. Because you have here x to the power 1. So when you integrate, so one power is increased in the numerator in the variable. So x to the power 1 is there. So it will be 1 plus 1 means x square, x 1 plus 1 2 x to the x square, and that 2 will be in the denominator also. So you have the integration x square by 2. Now for about this term, you have this is 2x plus 1 upon x square minus 1. When you divide by x square minus 1 in both terms separately, so you have this 2x upon x square minus 1 upon and plus 1 upon x square minus 1. Okay, you have this. Now in the second integration, you can see that 2x is the differentiation of the denominator. In the denominator, you have x square minus 1, and its differentiation is 2x, which is present in the numerator. Okay, so you can apply that result. So it gives you log of the denominator. So log of x square minus 1. Okay, what about third one? Third one is of the form integration of x square minus a square. It is of this form. And you have 1 in place of a. So according to the result, the formula is 1 upon 2a. So a is 1, so that is 1 upon 2 ln x minus a upon x plus a. So a is 1, so x minus 1 ln x minus 1 upon x plus 1 plus c. So you have this thing. So are you getting it? Okay. Okay, Jasim, Jordi. See the next one. In the previous one, in before this, we have this px plus q, this px plus q upon a is x square plus bx plus c. Okay. So in this, what we did, we write px plus q as linear combination, means lambda of differentiation of this polynomial in the denominator means 2ax plus b, and then plus mu. Okay, and there was no under root on the denominator function, but here you can see that you have px plus q upon under root of ax square plus bx plus c. Okay, so what to do in this case? So in this case also you will first find the same, you will do the same substitution, and you will find lambda and mu. Okay, so you will proceed similarly to that, and you will find lambda and mu. So you have this lambda and mu. Now, when you will put the lambda and mu in this, suppose this is equation 1. Okay, then what do you have? What do you have here when you substitute? So your given integration reduces to this. So what are you doing? This 2x plus 3 is written as like this, because you have now 2x plus 3 equal to 1 time 2x plus 4 and minus 1. Okay, you have this. So by replacing that 2x plus 3, 1 time 2x plus 4 and minus 1, okay, then you have this under root term in the denominator. So dividing by that under root term separately, so you have these two integrations. Are you getting this step? Because it is written here directly. What I want, you must know how it is written. Are you getting it? Okay, Arnav, Jordi. Now the question is how to integrate. I told you the result when you have function in the numerator, which is the differentiation of the function in the denominator. But here you can see that in the denominator you have function, there is under root sign. Okay, because differentiation of the under root function is 2x plus 4, which is present in the numerator, but there is under root sign also. So it is not the differentiation of that under root function. Okay, that function with the square root, it is not the differentiation of that. So that is why we cannot apply the that result of integration of f dash x upon fx. So what we do? We take this function x square plus 4x plus 1 equal to t. Then differentiate on both sides. So you have 2x plus 4 dx equal to dt. Okay. So after using this substitution, this I1 becomes this dt upon under root t. Dt, this is dt now. Okay. Dt upon under root t. And under root t means t to the power minus half. 1 upon under root t means t to the power minus half dt. And its integration gives to the 1 is added in the power of the variable, So d to the power actually what? Minus half plus 1. So which is 1 by 2. So d to the power 1 by 2 upon 1 by 2. And t to the power 1 by 2 means t is what? T is x square plus 4x plus 1. And power half means this under. And 1 by 2 becomes 2. So this is the value of I1, first integration. Similarly, if you want to find integration of this I2 part, so in this case, you will make perfect square. Okay. So whenever you have function in the numerator, okay, so we always try to do like this by making it equal to the differentiation of the denominator or by using this. But if we have no function, there is constant only in the numerator and quadratic polynomial in the denominator, then what will you do? You will write perfect square form. Okay, you will write the function in perfect square or in the form of x square minus a square in that case. So you will apply identity. So in case of I2, what do you have? X square plus 4x plus 1 is written as this. Why 4 is added and subtracted? Because 4 by 2 is 2. What is 4? Coefficient of x. So coefficient of x is 4 and 4 by 2 is 2. So 2 square is added and subtracted. So 2 square means 4. So 4 is added and subtracted. Okay. So in this way, what do you have? The first three terms gives x plus 2 whole square minus 3. 3 means under root 3 square. So this becomes now in the form of under root x square minus a square. So you can apply the formula for this. I have already mentioned in the previous sheet. Okay. So you can directly apply the formula. According to the formula, it is ln a plus under root a square minus x square. So you can apply that formula. Okay. Now you have values of both I1 and I2. And I is equal to what? I1 plus I2. From this step, I is I1 plus I2. Okay. So you can substitute values of I1, I2. You have integration I. Is it okay? Okay. Let's move for the another method of integration, which is called as integration by parts. It is very important, and I will also tell you the shortcut of the integration by part for some kind of function. Okay. So what do we do in this integration by part? So if you have to integrate a product of two functions, if you have to integrate the product of two functions, suppose these functions are u and v, which are function of x, and you are integrating the product of these two. So this is equals to, this is defined as u and integration of v. Here we write u v according to first and second function. Suppose u is your first function and v is you are taking second function. How to decide it? I am going to tell you, don't worry. So this u is first function, v is second function. So this integration of the product is u as it is, then integration of second function minus inside the integration differentiation of the first function and integration of the second function, and then integration of the whole. Okay. So the question is, we know that okay we know how to differentiate, how to integrate, but question is how to choose first function or second function. So for choosing first function, there is a rule. According to that rule, this rule is called as ilet. I means inverse trigonometric function, log L means logarithmic function, A means algebraic function, T means trigonometric function, E means exponential function. So we take the first function according to this rule. If inverse trigonometric function is present there, then that will be chosen as first function. Then if logarithmic term is there, then say first function. So you will proceed in this, in the according to this rule, okay, and you will decide your first and second function. So let us discuss some questions. You have to integrate x sine 3x, x sine 3x. You have to integrate it. So according to Euler rule, what is Euler rule says? Euler inverse trigonometric is not there. Logarithmic function is not there. This is not there. This is not there. Algebraic function, A means algebraic function is there, and T means trigonometric. So A and T both are there. So but when we are moving from left to right, okay, so we have first algebraic function, then trigonometric. So that is why I have written here first for algebraic function x and trigonometry, and sin 3x as second function, trigonometric function. Yes, Shiva. Okay, so this eyelet rule helps us to choose the first function. Okay, so there was no inverse trigonometric function, no logarithmic function, there was algebraic function, and algebraic function is x. That is why it is taken as first function. Okay, so if it is first function, so next function sin 3x will be second function. Okay, now what will you do according to the formula? The formula says, the above formula says u first function as it is, integration of second. So that is why first function x is as it is, integration of sin 3x, then minus, then integration of what? Differentiation of first, integration of second, and the integration of the whole. Okay, so in this integration of sin 3x is what? Minus cos 3x upon 3. Okay, do you know how is this minus cos 3x plus 3? You know, actually, I have also mentioned the formula of integration of sine ax plus b. Yes, it is formula. So integration of sine x is minus cos ax plus b. Okay, upon differentiation of this ax plus b is a. So upon a. Yeah, I have mentioned this one. Yes, Anna, it is formula. Okay, so that is why here you have a equal to 3 or b is 0. So sin 3x is integration of sin 3x is minus cos 3x upon 3. Then minus, then differentiation of x is 1. Integration of sin 3x is minus cos 3x upon 3. Okay, now the first two term gives this minus x by 3 cos 3x, then minus minus plus integration of cos 3x is again sin 3x upon 3. Differentiation of sin 3x is what? 3 cos 3x. You know that. You can also learn in that way. Differentiation of uh, sin 3x is what? 3 cos 3x. So integration of cos 3x is integration of this cos 3x gives this upon this. Sin 3x upon, okay. So sin 3x upon, then plus c. Okay, so 3 3 are 9. So you have this answer. So in this way, you can use this formula by part integration. Can you try the next one? You can also do this by shortcut, which will I'll tell you after this. Okay. Otherwise, you can do it by taking first and second function, and you can find the integration. Can you find it? Can you find it? Let's see here. If you will check using by using eyelet, so by eyelet rule, inverse trigonometric is not there, logarithmic function is not there, only your algebraic is there. Okay, so algebraic is there, that is why x square is taken as first function and e to the power x is second function. Yes, Jordi. So by applying the formula, so according to that, it is equal to what? First function as it is, integration of second minus inside the integration, differentiation of first function, then integration of second function, then integration of the whole function. Okay, so this is x square e to the power x minus integration, it is now x 2x into e to the power x dx. Integration of e to the power x is e to the power x, differentiation of x square is 2x. Now again you can see there is product inside the integration, x into e to the power x. So you, what will you do? You will again apply the formula. This is now first, this is second. So you have first function as it is, integration of second function minus inside the integration, differentiation of first, then integration of second, then integration of the whole. So you have what? You have x square e to the power x minus 2x e to the power x minus differentiation of x is 1 e to the power x. And there this is minus and minus, so minus minus plus. I think just a minute. X e to the power x minus, yes, this is minus 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 plus this one, and again here you have here integration sign, and 2 is also there. Okay, so this is what x square e to the power x minus 2x e to the power x plus 2 e to the power x plus c. Are you getting it? What about others? Okay, let's move to the next one, question third. In this, only ln x is there in the integration. So how will you do it? So in such case, we take another function as 1. Okay, ln x into 1. Okay, now we will decide first and second function by eyelet rule. So in eyelet rule, inverse trigonometric is not there, then logarithmic function is there. So it is taken as first function. Okay, then another function is taken as second function. Now I have applied only the formula. In the first integration, inside the integration, I have 1. Integration of 1 is x. In next integration, integration of 1 is x here. Differentiation of ln x is 1 by x. Then x cancel out. Integration 1 is left in the integration. Integration of 1 is x and plus c. So this is your answer. This is integration of ln x. Is it okay? Okay. Then see the next result for the integration. This gives the integration of the type of the function. If you have e to the power x and inside the bracket you have fx plus f dash x, means fx and its derivative both are present in the addition. Then and outside of that addition e to the power x is there. Then integration is what? Integration is e to the power x fx. So if you find any such function in this form, so you can apply the formula directly. So in the first example, you can see that you have e to the power x into 1 by x minus 1 up by x square. So this minus 1 by x square is what? This is differentiation of this. I have also mentioned here. Okay. So actually what do you have? You have e to the power x, in the bracket you have 1 by x and plus differentiation of this 1 by x. Okay. You have like this. And the result says it becomes e to the power x fx. So e to the power x into 1 by x and plus. Okay. But in the next question, e to the power x is there, but we don't have the sum of two functions, function and its derivative. We don't have like that. But can we write in that form? So answer is yes. So you have given x upon x plus 1 whole square. If you add 1 and subtract 1. So you have this. Okay, you divide by this x plus 1 whole square in both x plus 1 and a minus 1. So you will left with this. Okay, so actually what I have done, I have written like this: x plus 1 upon x plus 1 whole square minus 1 upon x plus 1 whole square. So this will cancel out. So this is 1 upon x plus 1, this term, and this is this term. Okay, now again you can see that this second term is what? This is differentiation of the first term. This is actually differentiation of this first term. Okay, so the formula is applicable here. So that is why it is answer is e to the power x into 1 upon 1 plus x plus c. Is it okay to all? Okay. Let's move to the next. These are very important results. I'm not discussing their proofs. Okay, and but these are very useful whenever you will study Fourier series, and whenever you deal with the problems in Laplace transform and many other places, you will see that these formulas are applied there. Okay, so you must remember these. So in this, you can see that in this formula, I'm just going to discuss, explain the formulation of these. You can see that you have e to the power ax into sine bx. Okay, so e to the power ax is as it is, and here it is a and b inside the signs. Exponential, in exponential you have constant a, and in the trigonometric function sine you have constant b. So you can see that here it is denominator a square plus b square. Okay, similarly if I talk about the next formula, e to the power ax into cos bx. So again you have coefficient here a and here b. So e to the power ax is as it is, and in the denominator you have a square plus b square. So you can see that this term is same in both. Either you are doing for e to the power ax sin bx or e to the power ax for into cos bx. So you have the same term e to the power ax upon a square plus b square. Okay. Now what is the term inside the bracket? So I always remember this by using this. First, suppose I take another color. I take this constant a and sin bx. So this is a sin bx. Okay, this a and sin bx. Now what you do? Now replace this a by b, because a is already there. So in the next term there is b. In the first term sin is there. So in the next term this will be cos. So a, then next one term of b. For in first term you have sine function. So in the next term it will be cos function. Okay, and in the angle inside trigonometric function, that will be same. It is sin bx, or in the second place you have cos bx. So a b sin cos. Okay, and this, what about this middle, this sign? Why it is minus? You can remember this. Why? Because you are taking sin bx here, which is odd function. So if it is odd function, so you have minus sign. In the next one you can see that there is plus sign, because cos function is even function. Okay, so similarly you can memorize the next formula, this a constant and cos bx as it is. Okay, so first you will write a and the function cos bx which is present in the integration. Same you will write. Then in the next term you will replace a by b and cos by sine. Okay, in the first one, you have to replace sine by cos and a by b. Okay, in this a by b and cos by sine. Okay, for even function, cos function, it is plus sign in the middle of these two terms. For sine bx, e to the power ax sine bx, if sine bx is odd, so that is why there was minus sign in the middle of these two terms. Okay, I hope you are getting what I want to say. I want to say how to memorize this formula, because many times, what happens? Students make mistakes while applying these formulas. So you must remember correctly. Okay. So in the next question, you have the this e to the power 2x and 3x. So you can see that here a is 2 and b is 3. So I have directly applied the formula e to the power ax, this term as it is, 1 upon a square plus 3 square b square. A is 2, so 2 square is 4, 3 square is 9, so 4 plus 9. Then a sine bx, a means 2, 2 sine 3x minus, now a is replaced with this b means 3, and sine is replaced with cos, so cos 3x. Okay, so you have this one. This is your answer. In the next one, you have e to the power minus x cos x. Here a is minus 1, b is 1. So e to the power minus x as it is, and a square plus b square is what? Minus 1 square plus 1 square. This thing, which is 2. Okay. Then a is minus 1, so minus cos x. Then for cos function, you have plus in the middle. Then this minus 1 is replaced with plus 1. Okay. Cos is replaced with sine function. Okay. So in this way, you can do. Now I'm going to tell you the shortcut for by part method for the function of the type x to the power n fx. When you will learn this formula, you will never apply by part for such function x to the power n fx, because I never apply that. I always use this shortcut, always. And you will also like this. So you know that if you want to find the integration of x squared sine 2x, okay, so when you will use by part method, it will be done in 2 or 3 steps. But when you do by this shortcut, it will be done in the only one step. Actually, I also don't make this table many times. I write it directly. But for you, I have mentioned this table. Okay, this will help you to learn it easily. Otherwise, I always write in the directly in the one line. So see what happens here. How to apply this? So your first function is x square and second function is sine 2x. How? By the Eilert rule. Okay, Eilert rule is applicable here to choose first and second function. So what will you do here? D means derivative, I means integration. So you will differentiate the first function. So you can see that x square differentiation is 2x, and again its differentiation is 2 and then 0. So you will find differentiation of the first function till you get 0. Okay, because it is of the type x to the power n, so definitely its power will decrease and will go to its differentiation will go to 0. Then for the second function, you have to I means integrate. So you have to integrate sine 2x is integrated. Okay. So when you will integrate it, you will get minus cos 2x by 2. Then you will integrate this, you have this function. Then again its integration, this function. So integration term will not go to 0, but the term for which you are finding differentiation of the form x to the power n, definitely its differentiation will go to 0. So you have to first do the differentiation of the first function, okay, till it goes to 0, and then you have to find the integration of the second term, okay, until you have 0 here. Okay, now what will you do? You will put sign here, plus minus alternatively. You will put sign before the terms that you have written in the derivative column. Now what will you do? You will multiply like this. Multiply by x square in this term.